Welcome, everybody. We're going to be looking at our Unit 9 material tonight for natural language processing, which focuses on neural language models. If you recall, let me just get into my cursor here. Last week, we talked about these topics. I'm not going to regurgitate them. Our agenda for tonight is to go through these things. So these are generally things that we've talked about before, but we're getting a little deeper and a little bit more technical on them. And we're going to be trying a bunch of different models and looking at code and different platforms and stuff. I'm hoping that we don't have too many hiccups because as I run this, there were headlines today that we had some cloud network outages from Azure, and AWS was affected a little bit. And of course, the big hit, of course, is Minecraft was down. So like none of the Minecraft people, but you know, with the Microsoft Azure cloud going down, a lot of Microsoft products were inaccessible for a while earlier today, including Microsoft Office Online, which is pretty major, right? And think about how many people use that software. I mean, it's everywhere. So just be mindful, like some things that we do might not work because of that. I don't think that any of the links I tried that failed before were due to that, but who knows? I was actually trying to go online a little earlier today and pay my utility bill with We Energies, and I couldn't log into their system because their user login system was down, which must have been related to that. I've never seen that before on their website. Right, not a big deal. They can wait a day to get my money anyhow. So, right, I always hate paying that electric bill. All right, we're going to talk first about language modeling and kind of a little bit of recap here, I suppose. But it says last week we looked at language models and how they basically learn to predict the probability within a sequence of words, like what word comes next. They also are able to look at the rules of a language, you know, whether it's like English or maybe it's a coding language or whatever. And basically the language models fall into these two large categories. We have statistical models, which are basically like n-grams, and they use, you know, they're based on linguistic rules and look at the probability of words occurring, right? So it's like what word follows another is really just based on statistics. And I think that's kind of interesting. And then we have the neural language model approach, which is more of what we're going to sort of focus on tonight. And it uses basically neural networks to predict the probability of words. And there's a little chart that's coming up that I think shows a really nice little example of like how the two differ, right? Because the n-gram approach is kind of like where all of our voice assistants started. You know, like how long has Siri been out? A pretty long time. And it's not like it came out 2 years ago. It's been around for 10, 15 years. And so like some of this stuff was already in play quite a while ago, right? We just didn't think of it as AI, but in a sense, it was the fundamental parts of AI coming out. Now we have these neural language models, which are where a lot of our generative AI stuff comes from. And the output of those models is a lot more, for lack of a better word, I'll say creative or resourceful on the model's part. The statistical model, right? And so just kind of review some of the concepts here again. We basically just look at the straight up probability of a word occurring given another word occurring before it. So if I say the word, the cat blank, you know, I don't know, what did the cat do? The cat slept, the cat ate, the cat cuddled, or whatever, right? Like, what's the next logical word? And there's probably like, I don't know, 100 words you could put after that. And then we can rank them, take statistics on them, and based on what seems logical to follow, you know, that's kind of where that comes from. The weird part about that is it only really truly looks at the word that just preceded it. It doesn't look at like the whole sentence, right? That came before it. It just looks at the one preceding word. And I did like put him into my phrase, mind you. I said the cat, and then I said blank. But really, the is a stop word, right? We would just throw that out anyhow. So we're going cat blank, right? And most likely it would be a verb, that kind of thing. All right. There are some limitations of n-grams, right? Even though they're powerful, um, they generally, right, do better with a larger n, meaning, the larger number of words being fed into it. So like if we're right, so like keep in mind, like with n-grams, the reason we say n is because if we sometimes do bigrams or trigrams or quadgrams or whatever, right? Like we really look at phrases, right? And so the larger the n, the better the model performs. So like very commonly, a lot of the n-gram models are like you ask it a question, and in the form of a question, and you say, how do I, blank, right? And it leads it down a certain path, right? So the bigger the n-gram, the larger the n, the better the model does. They make a point here that it does exert a lot of pressure on computational resources, though, very particularly the RAM of the system running the algorithms, right? So it's not like when programs are crunching data, they don't do that on the hard drive, right? They load the stuff into memory and it happens in memory. So it's very memory intensive. So systems that run big, language models basically usually have lots of CPUs, lots of storage, but also lots of RAM, and and generally speaking, when you're computing, more RAM is better, for just getting tasks done. It says the n-gram model gives zero probability to all the words not present in the training corpus. So think about what that just means, right? So if I'm training a model with a set of words, I might not be using like every word that's available, right? It's not like I'm taking the Webster's dictionary and dumping it into the model, right? I might be just looking at, let's say, a bunch of Wikipedia articles about what cats do, right? And so those models might ignore other words like, that wouldn't be part of that data set. And so those words aren't even part of the model. But in reality, as a human being, even the words we might not use are still part of our vocabulary, but for the model, they're not, right? So that's kind of limiting, and that a little bit problematic. It says here the language models it says occupy a crucial role in NLP modeling, absolutely. And it really does look at how different human languages have different patterns. Okay. And they point out the fact that these approaches do sit behind all the key voice assistants that we use. And these are probably the top three, right? I've actively used both Siri and Google. I've played a little bit with Alexa, but I really don't like buy into the Amazon platform. I don't have like an Amazon Echo or anything like that at home. But I do have lots of Apple products, and I have lots of Android and Google usage. So I do use those quite a bit. I did always find it very disconcerting, though, especially when the search engine thing came out. Like you bring up like a browser tab, and I'm going to try to do that here if I can get all these windows out of the way, right? And when they first put the microphone on the search bar in Google, that I would just say, okay, Google, and it would just start typing, right? And I did have my phone set up that way at one point. I don't know if it still does it. Okay, Google. Okay, my phone's not doing it. I don't have it turned down. That's fine by me. But if you guys remember my old phone before I smashed it in the car door, it would always trigger on every time I said that. And sometimes I was saying it, unwittingly. And these days you really have to click it on to do that. But it is understanding you, and it is converting your voice to text. I think that's insanely powerful. And it's also pointing out the fact here that we do also use neural networks, right, to do language modeling, and that's kind of the pathway we're walking down here. So we started with n-grams. We've been doing that for quite a while. They do have limitations, so we're just kind of reinforcing that. But now that we're in this modern era of what we call large language models with natural language processing, significantly more advanced models that are built on neural networks. Um, they do, as it says here, provide more creative and contextually relevant sentence generation. And I am pretty impressed with some of the tools. I was playing with Grammarly last week because the school gave us, some of us instructors here, free trials on it, to help me write some curriculum content for our repository. And I was pretty darn impressed, at some of the suggestions that made, because I think I'm an okay writer, and then I put it into Grammarly and it did make some suggestions. I'm like, yeah, that is much better. Thank you. And then I know I can do it with ChatGPT and other models, but Grammarly is really kind of built for creating good content. All right, so let's look at this little chart here because I think this is actually pretty helpful. On the left, we're looking at n-gram models, so kind of where we were coming from, and now that we're in the Gen AI era, the difference, right? So n-grams rely on statistical patterns of information, right? So we got that going on, where the Gen AI uses advanced techniques like deep learning and neural networks. We already saw the difference, like n-grams, trigrams, bigrams, whatever, versus deep learning, right? A lot more complicated deep learning, right? It takes longer to train the models, but you get much better results. N-grams predict the next word, basically based on n-gram frequencies. So they look at statistics, basically, to determine what word is likely to come next and guess, right? It has nothing to do with knowledge. It's really all about statistics, right? And the Gen AI learns semantic relationships. In other words, semantic means the meaning, so related meanings of words, and looks at the context of like the sentence it's sitting inside of, to generate the information. Much different, right? So it's looking more holistically like we would as humans, basically. N-grams are limited in generating creative and contextually relevant sentences. They're not clever. If I'm in my email and I put you in my to field and then I type hi and it types in your name, that's not really a whole lot of intelligence, right? You know what I mean? It's just pulling your name from your email. That's what it's doing, right? It's not really super smart. If you look at what Gen AI does, it is capable of generating, it says, diverse and contextually fitting sentences, like to a really high level, much higher level. N-grams are limited because of the limited scope of the n-gram models. Not that they're bad, but they are limited. While Gen AI can improve the accuracy of output using advanced techniques such as smoothing, interpolation, and backoff, which are mathematical techniques for revising itself in the model, and therefore comes up with much better results. They have a little example at the bottom, which I think is kind of nice. So this says, the cat sat on the blank, right? So n-grams would predict common words like mat or chair or something like that, right? And for me, it would be sitting on my wool coat and leaving all the cat hair on the coat. That's kind of a pet peeve. I don't know if you guys have a cat that does that. I had one cat that would literally pull my coat off the coat rack just to sleep on it. I don't know how it pulled it off, but it did it. Right. Okay. The other example for Gen AI, notice the difference, right? The cat sat on the cozy windowsill. There's modifiers added to it. It's not a single word prediction. It's a multi-word. It's a phrase and it's more meaningful. Or it might say the cat sat on the cushioned armchair, right? And see how more relevant that is. More imaginative, more relevant contextually. All right, let's start to look at some neural language models now. And here we start to bring up coding examples. And here's what I'm going to tell you about the coding examples. Obviously, like without us running the code doesn't really have a lot of impact. We're just kind of looking at the general approach. The other thing that you're going to learn here as we're stepping through these slides and some of the external examples we're going to look at, a lot of the external examples are going to drive you to websites where you can pull the models down, learn how to add the models to Python code, show you examples of how to utilize the models, and real frankly, uh, build your own stuff based upon those large language models. And I think that's really kind of exciting, ultimately. Um, all right. So when we start to look at neural language models, and this is just kind of a breakdown of the process more so than actually like worrying so much about the code. But you notice like the comments they have here, right? So first you define the model, so you pull in all the tools and add all the components given the syntax that's appropriate for whatever tool you're using. Um, and then you compile the model, meaning that you process it, right? And see, this is kind of a weird word to use inside of Python because in Python we don't really compile our code, right? We just execute instructions. But the model has to be compiled in that you have to process the data of the model in order to get the model to work, right? An interesting little aspect of this is depending on which, let's say, publicly available open source language model you look at, some people will let you look at the data that they're using to train their model so that you can tweak it and adjust it, and some do not. Okay, why would they not? So, for example, if you're looking at a company like Anthropic or OpenAI, one of those companies, right, like big AI companies, they put a lot of time into training their models and getting them to work right. They don't want you to see the secret. They don't want you to see the like Coca-Cola's like 13 secret ingredients or whatever they are, right? You're not going to look at that recipe, but they will tell you that it is that they're trained on public data or they're trained on this, and what that specifically is, we just don't know. So you define, you compile, and then you fit the model to your basically situation or scale it appropriately. A lot of neural network models actually are built with a lot of little what we call submodels, right? So like whenever we're processing data through a neural network, think about this. Each node can have a very different kind of formula in it. The pathways have different weights applied to them. And then we have neural network models that recirculate the data and go backwards, and some that only are feed forward, right? All those things that we talked about. Um, Here, if you look at this little piece, it says with neural network model code, you would generally look like what we saw in the previous slide, right? So like um, the code that we were seeing on the screen. It says there's two ways to build it with using Keras, either what we call sequential or functional. Sequential have an approach that they use, and notice it's a logical guideline for stacking layers one after another. Moreover, they are incredibly easy to follow. So it's a very clear pathway. There's a tutorial coming up here, and I'm not going to say it's not really a tutorial per se, but more informational. What I do suggest, and I think I have these tabs open. I'm trying to find my browser window here. I just have to make sure I'm looking at the right stuff. Okay. So this first link, which does work, takes us to this article. And I think this is a pretty neat article. And I want you to notice the website. Obviously, what they're trying to do here is they're trying to get you to sign up for their courses online, and that's on you if you want to sign up for it. But they do provide a lot of information that's helpful here. Their ads are very, very annoying. Oh my God, right? All right. Here's what I do with very annoying websites with bad ads is that's when I revert to my Brave browser usually. And that usually gets rid of all the ads. Thank you. There we go. Much better, right? Yeah. Highly recommended browser, by the way, just for that reason. This is a really cool article, by the way, because they talk about basically the process of doing some of these tasks. I want you to notice the date of the article goes back to 2020. So it's not like brand new, but this information is still highly relevant. And they talk about, so if you go through this tutorial here, basically the difference between sequential and functional APIs, how to define multi-layer perceptrons, convolution networks, recurrent neural networks, using the functional API, so like code that other people have created, and how to make more complex models with shared layers and multiple inputs and outputs, right? So that's kind of the overview. These are some of the topics that they walk through, right? And then they go through the process of showing you the code, right? And like if you were going to do sequential models with Keras, like here's the libraries you import, here's how you set up your models. They show you how to do functional models, and when you get to the functional ones, there's more steps. So you got to define your inputs, you got to connect your layers, create the model. Then they go into standard network models, right? Multi-layer perceptrons, and they go on and on and on. And I'm not going to because you can see I'm at the very top of the page here. I'm just like starting to touch on the topics. And there's a lot of information here. There's a lot of good information here. So I would strongly suggest you go through it and check it out. And look at the difference with the ads. Like, oh my God. I don't know if they're like websites crashing or something like that. All right. Let me get back to the PowerPoint here. Somewhere. 3 clicks back. All right, let's move on to the next slide. They do talk about some of the things that we were just looking at in that article, including sequential models. So that basically adding layers one after the other, right? So these are examples of layers that we might add. So we have an embedding layer, a GRU layer, and a softmax layer. So the embedding layer basically is when we go past the input layer, it's the first hidden layer in the neural network. And notice it says word embedding represents words and documents with a dense vector representation, initialized with random weights, and will learn embedding for all words in the training data set. So whatever words we pump into it. Okay, now we are supposed to, when we're using this embedding, right, set up an input dim, which is the size of the vocabulary in the text that we're feeding it, and then the output, which is how many vectors we're outputting as a result, and then the input length, which is the length of input sequences. Now, if you can imagine, I conceptualize this. What if you're feeding it all the information on Wikipedia? Okay, that's more than a couple sentences, right? That's a lot of information. Or what if you're feeding it all the news headlines and abstracts from Reuters or the Associated Press? And by the way, those 3 sources are some of the 3 big sources for most public-facing AI training models for linguistics. And I think that's fascinating to think about. No wonder the content's messed up, right? The embedding layer can be used as follows, right? So it can be used alone to learn word embedding that can be saved and used later. It can be used to load pre-trained word embedding models, and that's a really common approach. So like if you use like GPT-2 that we're going to look at in a little bit, they already trained it. Do you want to retrain it? Because it took them a while to train it. So why not just use their training that's already there? If you have some specified reason to custom train it, then you do that, right? And a lot of companies do that. And it can be used as part of a deep learning model where the embedding is learned along with the model itself. Okay. The GRU, and by the way, that stands for gated recurrent unit. And think about what recurrent means, right? Like it's feeding back on itself. So this is part of the recurrent neural network aspects. Basically, gated indicates that we might allow the traffic or the information through, or we might not. It's controlled, right? And notice it says different structures called update and reset gate to control that information passed to the output. So it does, so for example, if there's information that is relevant to the solution, it'll move that information forward or back through. If it's not, it kind of says, well, we really don't need this, right? Yeah, that's the gated part of it. All right. Then we have the softmax layer. And as it says here, it's generally used as the last layer of a neural network. And that's usually the one that does the classification process. And when we say the last layer, we mean the last hidden layer, by the way. Its purpose is to return the probability of a data point belonging to each different class, since we're classifying. And it gives you an example, and it says, like, for example, if you have 3 classes, it will return the probability of the data point belonging to class A, B, or C with all the probabilities adding up to 1, right? So we can get percentages. But if there's 3 possible outputs, it's going to rank the probabilities based upon those 3 possible outputs. If it was 4, if it was 100, whatever it might happen to be. All right. So neural language models, it says here, found applications in a bunch of different things, including natural language processing, such as language generation, machine translation, sentiment analysis, and more. A lot of the stuff we've been talking about. Really popular usage is completing sentences or generating text based on a given prompt, right? Completing sentences, like I think we see this, like, for example, in our like email programs, we've talked about this, or if you're in, certain text creation tools. I mean, heck, even think about your text messages on your phone as you're typing stuff. And I was like, I think it certainly learns my patterns, and I don't know if it's based on engrams. Like if I'm sending a message to the kids, like, what do you want? And then it knows to say for and dinner next. You know what I mean? I don't have to always type that stuff. So here they're pointing us towards a demo, and this is one of the things that I could not pull up live on screen, although I found a lot of great resources in the process of looking for it, which I'm about to share with you guys. So let's take a look. But basically, they start talking about GPT-2. For those of you that use ChatGPT, right? They have gone through several models. The one that most people, I think, use now in their browser is either 3 or 4. Some people are using the version 5 model, although on a limited basis typically. And then the higher level models usually you have to pay for, or you get super limited use of them. But a lot of these older models like GPT-2, like when the AI thing started to first hit, it was GPT-2 that was really the big explosion. They do have a link here, and they allude to the fact that there should be a little box there that you can type stuff into, right? And we just don't get to it. And so what I'll give you is a couple of practical thoughts about this, and I'm going to do this inside of Chrome since I normally do my AI stuff inside of here. But if you go to ChatGPT and you come up here, you can switch which models. And I'm trying to figure out where that happens now. They used to have just a little drop down here, right? Where you could pick which model. And so they're not telling you which version it is here. And any of you that pay for this know how to switch to the older models. I mean, they used to have that as an option. Anyhow, what I was hoping to do is like go, oh, if you just come here, switch it to 2, it's the same thing as that box, basically. I'm guessing now that this is version 3 and this is version 4 and 5. Do any of you that pay know? Okay. Okay. And I really didn't not want to go to a temporary chat. And all right, so let's just like not worry about like actually having that little demo because I don't have a live one. Now, if you do follow this link, and I'm going to follow it, it's going to open up in my browser, even though I already have it loaded. We end up on the Hugging Face website. And I want you to notice that they start talking about this language model. They have a ton of information about it. And so this is, one of the reasons why this website's pretty darn useful. These Hugging Face models are a lot of the open source ones here that a lot of the other AI engines use as a basis for doing their more modern work. And they do talk about, for example, details about the model, including some of the stuff we saw on the slide. But apparently, the GPT-2 large model has 774 million parameters. All right, I want you to think about a Python program where you write like a function and you have like 3 or 4 parameters, right? And so then like you're dealing with a language model that's got multi-million parameters that it's thrown around as data points and analyzing. I mean, that's just insane, right? Just to even conceptualize it. And then, okay, let's take it a step further. That's version 2. And then 3 came out and 4 came out. Now they're on 5, right? So you can only imagine the scale that it's grown to. It says it's a transformer based language model created and released by OpenAI. So OpenAI, which is one of the big AI companies, created it and released it, and you can use it. All the code tools are here on this website, right? The model is pre-trained on English and using a casual language modeling objective, right? That's kind of scary sounding, right? Because what is it doing? Looking at Facebook? That's pretty casual, right? But it kind of is, and really, what the implication there is it's using public-facing information again. They have other models here that are related, right? So you can see, and I'm just wondering, like, if I clicked on, and I'm just going to go back here to the PowerPoint. Now they are pointing to the large model. Anyhow, if you start to read through here, they start to give you sample code, right? So you guys will notice, like right off the bat, that they have, and you can tell this is all Python code, right? It doesn't take an expert to figure that out, and they show you a bunch of different things, and notice that they have like pre-configured outputs, right? So like what it puts up on the screen is not accidental, right? And maybe it like randomly selects from one of those when you talk to it. They show you how to use it if you're using PyTorch. They show you how to use it if you're using TensorFlow, like all the syntax for bringing the stuff in. And I want you to be mindful of the fact that you don't get to look at the model itself necessarily, or the training data, but you get to utilize it in your programs. That's kind of crazy cool, right? I mean, if you start to think about that. Okay, so like for example, they start to talk about like direct use and downstream use. Says the primary intended users of these models are AI researchers and practitioners. And guess what? You guys are falling into that category now, right? Because what are we doing? We're researching this stuff, we're learning about it, and it's a process, right? You can't dive into the deep end of the pool necessarily and know how to swim with this stuff. It takes a while to get there. We primarily imagine these language models will be used by researchers to better understand the behaviors, capabilities, biases, constraints of large-scale generative language models. Okay, so they're teaching you about these things, is what they're saying. Here's some secondary use cases. It says writing assistance, okay, grammar, auto completion, creative writing and art, right? Fictional tests, aiding creation of poetry and other literary art, creation of games, chatbots, and amusing things. All right. Misuse and out of scope. And I think this is where it gets interesting, right? Like, okay, that's great. What's the downside? Right. And I think this is kind of telling. It says, because of large scale language models like GPT-2 do not distinguish fact from fiction, we don't support use cases that require the generated text to be true. That's pretty heavy right there, right? I want you to think about what that just said, right? We're using this to generate stuff, but you don't count on it being real or true or right, basically. So additionally, these reflect biases inherent to systems that they were trained on. So we do not recommend that they be deployed into systems that interact with humans unless the deployers first carry out a study of biases relevant to the intended use case. So like if I was using this to determine like, if I should issue like a speeding ticket to somebody, right? This might bias against certain people, you know, like young people are a lot more likely to get speeding tickets than old people like me. I mean, it's true, right? This is kind of how it is. Um, and We found no statistically significant difference in gender, race, religious biases between 774 million and 1.5 billion, implying that all versions should be approached with similar levels of caution around use cases that are sensitive to biases. So they're telling you right up front, this is prone to give you biased information. Okay. Well, thank you for letting us know. But how many people even read this far? You get my drift on it, right? A lot of people don't. And I think I mentioned this a week or two ago in class that we had like an AI topic speaker keynote at our in-service for Gateway as we came into the semester. And she asked it to generate an image, and it was a highly biased image. It was racially biased, socially biased, except it was actually quite shocking. And she wasn't using GPT-2, she was using GPT-4 to generate it. And that, I'm like, so, all right, so that's the more evolved model and it still has bias in it. Yeah, so this is very, very interesting. So when you're generating content, I want you to think about that stuff, right? It's only as good as the data being fed in. They do kind of go through this process, right? And they show you examples. They talk about the training data, the procedure that they used, and it goes on and on, right? So they give you all this great information. Additionally, when you come up here at the top, right, they have all these different tools that they point to, right, that you can kind of intermix it with, right, and then here they have some places where you, if you want to deploy this model out in the wild, here's some cloud-based platforms where you could take this model, pay somebody a fee, and deploy it and start to use it. And of course, because the school doesn't give me a budget for this, I'm not doing that, right? However, if you wanted to use the model, they have a couple of suggestions here, right? And so they have a library that points to transformers, and I think I have that open. I'm not sure, but they also point to Kaggle and Google Colab, and I do want to talk about these tools. Now that you guys are becoming a little bit more Python expertise people, right? And this is really interesting. I know I have these tabs open, but when I clicked this Google Colab tab, it dropped me in to this interface. And I want to talk about this interface because this is a free tool, by the way. Google Colab is an online Python notebook environment, right? So, Jupyter Notebook and VS Code, if that's not enough, there's more tools out there that do this work. And what it does is it allows you to load up Python notebooks, run them in this space, and manipulate it kind of all within the Google environment. There's no cost to it. I think it's kind of crazy. But for example, they give you the code, right? They tell you to install this tool so you can hit the run button and make it run. And then you can come down here and set up a pipeline. And then you can load the model. They got the codes all pre-written. And then if you want to do more stuff with it, well, it's all right here. You just add your code to it and you can do stuff. It's kind of crazy, right? I don't have to pay for cloud storage. I don't have to have a super high level of expertise. I mean, clearly you have to have some. So somebody who doesn't know any Python, doesn't know any machine learning, doesn't know what any of this stuff means, can't come in here and really kind of create AI out of it, right? There is a learning curve and it takes a little while to get ramped up. So this is kind of my introduction both to this tool, right? and to the possibilities of it. Here's the catch with this platform when you use the free version. Notice what it says up here. Cannot save changes. So if I do something and it's like all really cool and it works and everything, oh well, the moment you close this browser tab, it's gone, right? You have to like get in there and copy all your code and kind of do it that way. But they're trying to lure you in, obviously, to do this professionally on their platform. What I have not experimented with, and I guess I probably owe it to myself to do this, is Gateway uses Google as a platform. I don't know, like if I sign into Collab with my other account, if I can. Oh, okay. So they don't give you access through Gateway. All right. It's still, yeah, it's not letting me switch. Okay. Sorry, not happening. Right. But free, they let you try it with my free Gmail account. It works, whatever, you know. So take it for whatever it's worth. All right, let's just keep kind of looking at a couple more examples here. The other example was here on Kaggle, right? And I thought this was kind of interesting because maybe I should re-trigger this from their website. Right. So I went here and I clicked on Kaggle. And I know that you guys all know that Kaggle is a website where I can go get data sets. I can get code from other people that have worked in this space. I didn't realize that they also had a live Python notebook on their website. And now I'm like getting all these crazy ideas, right? Like, okay, well, if they're giving you a Python notebook on the web too, I don't know. I mean, here it's kind of indicating that it's saving it, right? Because it says the draft is saved. Once again, it gives me the code, right? Set up a pipeline and load the model directly. Same stuff we were seeing on the other site, right? It's not different code. It's the same code, but now you're operating it inside of this space. And then if you get curious about it, you can kind of dig in. So, yeah, and they have a little error code thing here. But I was playing with this earlier, and I don't know if you guys saw the output, but for example, I did the pip install, I ran the pipeline, and I loaded the model, and it all worked. Right? It gave me some errors, but whatever. But basically, it did load it up, and then you can take it to the next level from there. Right? So that's kind of my sort of lame demo on this stuff, right? I wish I could go deeper with it given the time we have. We don't really have that luxury, unfortunately. We still have another 60 slides to go through in an hour as well. I think that maybe we should take a break here. I think we're getting to a break point. No, let's take a break right now. And it's 6:42. Let's come back at 6:47 and resume. All right, back from break, and now we're going to move on and start talking about the recurrent neural networks, which we have looked at before, right? But just kind of refresh some of the thoughts on this, right? And a big aspect of this is the fact that we can send information backwards through the network and basically have it sort of revise itself in the process, right? And I think this is really important because look at some of the things that it kind of gives you, because RNNs can remember important things about the input, so they see the pattern, and that helps them to be a lot more accurate in the what's next, basically. It says these are preferred for sequential data like speech or text, right? Because why? Because we talk in patterns. We have phrases we say all the times. Sentences are supposed to be structured in certain ways, right? If we're looking at computer code, that's got the same thing going on. It's got like certain syntactic approaches you're supposed to use. When we look at a normal neural network, right? Usually we just have one hidden layer, input layer, output layer, different pathways, and then it goes like that. With an RNN, any of the nodes, especially in the hidden layers, can have these little loop back things, right? The information can go back through a loop And that way it doesn't kind of like lose the information from before. These are all things we've talked about, which is why I'm going kind of quick on this. All right, but they give us an example, and the example says, imagine the input to your feed forward neural networks is the word Holmes, like Sherlock Holmes, right? You start typing HOL, right? It's processing it one by one. By the time it reaches M, it's already forgotten basically the HOL, right? So it cannot, um, in other words, a typical neural network doesn't have the ability to look back at its previous data and use that in its current data set. This is really kind of interesting, right? It's kind of like, having blinders on and not knowing, like what was I just saying? Did you ever have that effect? I mean, that's basically what's happening to a feed for it doesn't really worry about what happened before. The recurrent neural network can remember those characters because of the way that it stores information. Now, as you can imagine, right, if it's retaining that information, it's using a lot more memory and a lot more processing power to achieve it, right? Because it has to retain it, and it takes those things to do that. Um, and it says at the bottom, it produces output, copies it, and loops back into the network. Okay, yeah, pretty intuitive. All right. Here they have another little example here, and this is another one I was playing with, right? So they have this tool basically that allows you to do a text generation. I think this is another one that might be kind of fun to try here. Of course, this does have ads in it, so I'm tempted once again. Let's do the brave browser thing, right? Sorry, advertisers, we're circumventing your your strategy. This model here, and I want you just to read up on it like before you start using it. It says, try the AI text generator, a tool for content creation that leverages a transformer-like or transformer-based large language model to produce text that follows the user's instructions. As an AI generator, it offers a range of functions from text generation, completing sentences, predicting contextually relevant content, and it can serve as a word generator, sentence generator, et cetera, et cetera, et cetera. And I want you to notice here that there's a bunch of different tools associated with this stuff, right? And these are not the only tools. I have not played with this website a lot. This comes from Deep AI, by the way. So it's a different company. And hey, what we're doing here is we're trying different tools. The thing that I noticed before when I was tinkering with it is when I come in here, it gives me, and I want you to notice here, it gives me like whatever they consider standard. I don't know. And then you can go into math. And I think standard would be just the regular DeepSeek algorithm. Other DeepSeeks, including ChatGPT 4 and 5, right? And then notice I got Gemini in here, and Llama, and Grok, GPT-5 Nano, and they have a lot of models loaded in here, and you have them all at your fingertips, and you can try them all here. That's really cool, by the way, if you're not picking up on that. And it's kind of a thing. Now we have a little bit of a challenge here from the PowerPoint, right, where we can kind of play with it. And so this is what it's suggesting that we do, right? One by one, insert these phrases in the text box, and see the neural network complete the phrases for you. Okay, let's just try that. And I don't know if it really wants us to copy paste it or type it like we're normal people. All right, so I'm gonna assume the normal people thing. Who are you? All right. No, it's not really doing what I kind of anticipated, but let's just go ahead and click that. All right, and it's not doing the thing that I was hoping. And I think this is the tool, right? And I want to make sure I'm using the right model here. So I kind of think that I'm not, basically. All right, let's just play with it. I'm going to say happy birthday to it. It's kind of interesting. Okay. I'm not super impressed, but hey, whatever. And they kind of go on here. Um, and I'm not really sure where they're, I guess these are kind of frameless for me. So I don't really know where to go with them. So I'm going to kind of move past it, folks. All right. So they kind of make this point here that RNNs have two inputs, the present and the recent past. Like, what's the next piece of information that's happening now? And what were the previous pieces of information that were just kind of happening, right? Now, and we're not necessarily going way, way, way back. Um, the point is that the way the order of the information is important to predict what's coming next, right? And it does apply weights and all that stuff like we've learned in the past. And the recurrent part of it revises those weights as it goes through. They do have this whole uh, website and document here where they kind of get into uh, the depths of it. And I want you to notice this comes from Stanford, so this is not a lightweight course. By the way, they kind of really get into the math of it, and I would guess that you probably need to take calculus, a few levels of calculus before they'd let you take this class at Stanford. But they do talk about how the networks work. They show the formulas, they show the layouts, and we're about to look at some of this stuff. And yeah, those formulas get really hairy looking pretty quickly. They talk about the activation functions, but notice, even though maybe we are not math experts, at least the language of what we're talking about here is not foreign now, right? And I hope you guys are feeling that you're, even if you can't explain the math, at least you understand what this sort of means. And they do get pretty detailed about it and how it works, right? It's all mathematically driven and logic. So this is really a nice resource here. The thing that I think is interesting is how they have this website set up, and I'm pretty impressed with it. So good job, Stanford. Maybe it's worth paying the money to go to school there, right? Um, let's move on, right? They also have this interesting video here. I don't have time to play the video because it's like 23 minutes long or something, but this is a good watch. And it talks about how recurrent neural networks work. There's lots of nice little illustrations. It talks about a lot of the same stuff that you see in the Stanford site, by the way. Some of the highlights, right, of this information, that recurrent neural networks can have different ways they operate. And this graphic kind of nicely summarizes it. So, for example, we can have a network where we have one input path and one output, or one input and many outputs, many inputs and only one output, or many inputs and many outputs. It really kind of depends on what the goal of the network is, right? And that's all derived by like the problem you're trying to solve. They kind of talk a little bit here about the logic of it, right? And they try to break that down. And there is this little blog entry here that you can read up on too. That's not one I'm going to bring up on screen here. Now, if you think about this, like, okay, I have maybe one path in or one path out, or multiple in and one path out, and all those different variations. What are those used for? And here's kind of just a quick little chart. So you have a single input and multiple output. That might be used for image captioning. So we feed in one image, the image gets analyzed, and then we get captioning, which might be a series of words. So it's not outputting just one word. It might see in the image a dog, a cat, a banana, a car, right? And if it's captioning it, it wants to output all of those things, even though the input is singular. What about sentiment classification? All right. Um, I love it. I hate it. I'm not sure, for example, and then you come up with a score, you know. What about translation? Well, I'm putting in a series of words in one language. Now I need that series of words in a different language, right? Multiple inputs, multiple outputs. And I think that's kind of like good basic examples. They do start to give some use case scenarios here. So if you look at this aspect, right, it says given an image, produce a sentence describing its contents. And this is the thing that people do with AI these days. In fact, I think we played with a couple tools like this in our first class, if you remember. But basically, if we have an image, right, we throw the image in, and then it might give us a series of words. That would be an example. I think it's kind of an interesting one, but it can take like really what are a collection of pixels. And I think this is really fascinating from a technological standpoint, because when you take an image and you break it down into little tiny squares, right? Each square's got its own color, and then you put like several thousands of those pixels together and it forms an image. How is it that this technology is able to look at this like series of basically information and extract meaning from it to enough to provide a caption? I think that's fascinating, right? I mean, the complexity of what that represents. um so I mean, from a model standpoint, this is sort of what it looks like for example, we can look at this image and we see that there's a dog kind of hiding under the bed, right? And I can say that really quickly just by looking very quickly at the image. But this would pull this in through a convolution network. Then it would put it into an RNN, various layers. And as it's processing, it would start to generate the multiple outputs, which would be necessary to describe that image, right? Dog hiding under bed, might be like the core of it. Um, All right. So we use these for text summarization, right? We also use these for text generation, video tagging, that type of thing. And of course, we were playing with that weird engine here. And I think it would be kind of interesting if I grab maybe that image and ask it to describe the image. Should I try that? Yeah, let's give that a try. I think that might be kind of fun to maybe try to uh, I don't know. Maybe this one. This isn't really a great image though, because it's very, very tiny. But heck, you know what? The worst thing that'll happen is it fails, and we might have fun in the process. So I'm just going to screen capture this, right? And now it's in my snipping tool here. I'm going to go ahead and save this. Well, it just wants to put it into my screenshot, so I'll just let it do that. And I'll say dog. Actually, I'm not going to put a, you know what? I'm just going to call it ASDF, right? Because I don't want to like describe to it what the image is before I feed it in. But I think what I'm going to do now is I'm going to feed it an image, that image, right? So let's see if I can find it on my system here first. There it is. Go ahead and open that. And I'm going to say, please describe this image. Okay, let's see what it does. Oh, that was interesting. I asked it to describe the image, and what did it do? Yeah, weird. So it just gave me a picture of a different, it looks like a cute little puppy kind of hiding behind a blanket or something. Okay. I don't really kind of get why that is relevant. Could we try something else? And I'm going to bring up Chat GPT. And I'm not signed in, by the way. This is just in browser. Let's see if I can add an image, and it should let me. And I assume this is going to do a whole lot better than the tool that we were looking at. All right. And I think it did a much better job. I would guess that it's not resting or hiding comfortably. My guess is it did something wrong and the owner is angry and yelling at it and it's hiding under the bed. Right. That's my guess. Right. All right. Let's just leave it at that. Right. We can go down that rabbit hole pretty deep. All right. So text summarization, text generation, video tagging. All right. It says these types of networks, CNNs and RNNs are great for face recognition, emotion analysis, and with RNN being used for anything that's got a time series because it has a memory. Here's another tool I tried to get to, and then I got into trying to track the tool down because it's no longer at this link. And I'm just telling you guys that if you're trying to follow it, I could not find a live website where it was located. I thought we used this tool in the first AI class. You guys recall if this was the exact tool? And I just could not get it to work. I went down a rabbit hole of searching others that may have used the model to do the same thing, and I just could not find one. But they have a little demo here of how it works, right? Where you basically feed it information, right? You give it a file, you try it out, you upload one, right? And then it gives you the response in JSON. Do you guys remember doing this in that first AI class? Somebody remember it? Yeah, I vaguely remember it. So maybe it was just all in my imagination, right? Maybe I'm hallucinating like an AI. Who knows? All right, but notice what it did though. Its output is basically it creates a JSON file, like a Python dictionary, basically, where it indicates a caption, and then I want you to notice that it also ranks the caption with probabilities to what it likely might be. So it doesn't give you one answer; it gives you three, right? So the predictions are a motorcycle parked in front of a building, a motorcycle parked on the side of a street, whatever. We're not looking at the original image to know. Anyhow, all right. Advantages and limitations of RNN, right? So advantages, possibility of processing input of any length because it keeps things in memory, right? The model size is not increased with the size of the input. Okay, that's kind of interesting. And computation accounts for historical information, so it does look backwards. The limitations are computation is slow, so it's very processing intensive on the computer. It might be difficult to get to the information from a long time ago, and it cannot consider any future input for the current state. So it can't anticipate what you might add to it later, right? There's advanced versions of RNN, like LSTM and GRU that deal with the problems encountered with the traditional ones. And next we move on to named entity recognition, which is probably one of the more important topics here tonight. All right, so we've looked at this concept before too, right? Like where we're looking at, so for example, it finds the Food and Agriculture Organization and it identifies that as a thing, right? Or Summer Olympics as an event, that sort of recognition within the text. And once again, we have talked about this. They indicate here that this is really important in NLP, and you can use a trained model in Spacey to do this, right? And we've tried using that tool with mixed results, I think. But it's also possible to train the models for NLP using Spacey too, which they're going to show us basically in an example. So we can feed in information into these things, let the models learn them, and then generate whether or not it fits into one of these categories, like people, places, and things, for example, right? And so that's kind of cool. How do we implement this? Well, here's some sample code, but notice all the imports that you have to do to get it to work. And that's quite a number of libraries. Then we go into the process of training the data, right? So, for example, we need to provide information in a format that it can process it. And for example, if you try to break this down, you start realizing that these are like kind of parameters and stuff, right? So, given this question, what kind of responses might it have? What values would we apply to that? And so that would be a sample of the kind of data that you might feed in there. And of course, we would use software to help generate it to get into that format so we don't have to do it manually because that would be very cumbersome. Um, but what they're trying to show here with the syntax of this entry is really how it's breaking down. So, and I think this is a really telling slide. So, given the phrase "I like London and Robert," and we're just looking at the first three words now, they take that sequence of characters and break it down character by character. And for those of you that know, you know, uh, Python string structures or list structures, I mean, this is like a list of characters, basically, right? The locations, and I want you to look here, and it says 7. What's at 7? Well, London, right? Um, and so it's looking for entities, and it says at position 7 and at position 13, which might be something else, right? We don't really know. So it says here characters 7 to 13 of the sentence define London, right? So, and that is basically treated as a location. And then 18 to 24, which we can't see, but that's the person named Robert. And so this is kind of how like the data is broken down. So how it reads the data and processes it, this is the stuff it's processing. Kind of fascinating. Now think about it taking, let's say, the entirety of Wikipedia and processing it word by word. I mean, think of how long it would take us to just do a word or two. And even though the software can work a lot faster, it's still a heck of a lot of processing. They talk here about the data pipeline and how the stuff is loaded in, right? And kind of examples in code. Of course, we'll see this in our Python notebooks. They show here how to declare a simple pipeline. From there, they move on to the model training. I want you to notice how there's loops inside of loops here, right? Pretty complicated code, really, right? Once again, this is all pre-configured for us. And then they kind of still follow that format. Like all of that stuff that we were looking at, that data format does apply, right? And then and once again, named entity recognition, right? It's breaking stuff down into categories and then classifying it basically using that stuff. They show you the approach for training the model, right? And I know like functionally we're not coding here, so we're just kind of looking at the information. From there, it says here you can check your model in this way, right? And they give you the example. And notice that we're still following their format here, pretty much. So this might output something like this. London's a location, Robert's a person, Chris is a person, John Rogers is a person. So it's starting to recognize what stuff is. And you can see why that's really important, right, in this field. All right. From here, it says we move forward into the assembly line, or like basically a prediction. So after we have the model built, right, and trained and all that, we start to give it all that training data, and then it figures out what can come next, right? And I think this is kind of the grand goal of it. And it says, let's investigate how shortcomings of the traditional NER are being tackled by LLMs, right? So once again, the technology progresses. So we started with named entity recognition, and now we're working to these large language models. Here it says that with entity extraction using traditional NER systems, the machine learning algorithms use training based on context and syntax. It says one of the challenges is the limited recognition of native entities, requiring, for example, businesses to add taxonomy for specified named entity categories. So, for example, if I have, um, training my AI on Wikipedia, but then now I'm applying it to my company. Well, we got all this stuff within our company. We have products, we have people, we have information, we have knowledge. Now we got to train it on that. So even though it's a really good model, right now we still got to go through that process of training it on specific to our organization. So that takes a while. That is not a like, okay, let's just throw it in there, it'll be done tomorrow. It might take months or years to do the training completely. And that's kind of astounding to kind of think about because it's that complex. Um, it says that large language models leverage what they call pre-trained knowledge. So like, why do we use these big AI companies in their libraries is because they've done all the training already. They put in that work and now they're benefiting from it, but it also helps us to speed up our process of it. And so we don't have to train it on basic knowledge again. Now we're just giving it domain specific knowledge to train on. And so that should decrease the training time overall. All right, so then you start talking about this concept of zero shot classification, and they point out that the large language models use deep learning, right, for named entity recognition, and they adapt therefore to the nuances of the language being used. Um, the magic bullet empowering these is a thing called zero shot classification, which allows them to categorize and recognize entities without specific training data. Right. This is kind of interesting, I think, right? That they're able to do that. So they're not trained on it, but think about it as a human being, you can go out into a situation, you've never seen a scenario before, but you can kind of guess at what it is, even if you've never seen it before. Maybe you'll guess wrong, but maybe you'll guess right. That's kind of a zero shot example. It does leverage predefined entity labels and prompts to infer the right classifications. And so I think it's all very interesting, that it has that capability. It also is really good at understanding patterns, word entity relationships that help all that NER stuff. All right. We can optimize our large language models through how we do our prompt engineering. And I don't know how much you guys play with your AIs to get the right answers, but it is totally a thing. I have done little things in classes with students where we do some coding things, for example, and I challenge people to ask a question on how to solve a coding problem. And I find it really interesting the stuff that people type in to try to get an answer. And okay, and I don't mean to sound silly here, but I kind of like make this akin to like a conversation with my wife sometimes, and I'm not trying to like rank on her, but sometimes, like I'll ask her a question, right? And I think I'm being really clear about it, but I'm not, or vice versa, and maybe the question's really simple. Did you put the wash in the dryer? That kind of thing. It's like the answer is what, yes or no, right? But maybe, some other piece of information comes in and makes it kind of convoluted. The point is that if you put in the right type of prompt, you can coerce an AI to give you the right kind of answer. And you need to be specific, and you need to be verbose, and you need to be precise on your language. And I think it's kind of interesting when you're not, and you get something you don't expect as a result. Well-engineered prompts include context, data, and continuation description. I have seen people write prompts that will give an example of the kind of output they're looking for as part of the prompt. I don't know if you guys have ever tried that. All right. let's move forward here. We're just about done with the material, and we're just in the nick of time, by the way. Um, here's a problem statement, and it says sentiment analysis is a supervised machine learning technique used to analyze the particularity of sentiments within a text, either positive or negative. The problem being dealt with here is analyzing the sentiment from Twitter data, right? And I think we've looked at some of this data before. We're doing a sentiment analysis on hate speech, basically. This data set is live out there, if I remember. I did have it pulled up before. And you can access the data, right, if you wish. And there's also code examples that people have created. And I would encourage you guys to explore some of this. And I'm going to see if it loads up here. All right, so they have an example of their code. So if you wanted to like play with this data, and this is what I think is really fascinating about websites like this, people have done all this work and then they just share it all. And you can go out there and play with it and learn from it. Obviously, we don't have the time to do it here in class, but it is something you could totally do on your own. Notice that you can grab the file, right? And you can obviously adjust the CSV reader here, but you load up all your libraries, grab the file, train it, get some info about it, right? Now, all the kind of stuff that we do in a Python notebook, and all of the code is here. And I think this is just fascinating that it's all out there for the taking with a wonderful example, right? So just be mindful that that stuff is out there. Not sure what else to say about it. The pipeline structure, like, and this is kind of like regurgitating some of the stuff we've done, but right, you process or pre-process the text, remove stop words, punctuation. We look at URLs and Twitter handles, which basically have no value in terms of sentiment. And then we add unique pre-processed words to a vocabulary. So, like, in other words, once we strip away all the stuff we don't need, right? Links, hashtags, punctuation, and stop words, then we're kind of left with a body of words that might give us some more meaningful results. We have to go through the whole feature extraction process where we create a matrix, if you guys remember us doing that. And basically creating vectors and all that. And then finally we get to training the model, right? And in this case, they're talking about a logistic regression model. And then we get into testing it to see if the predictions are okay. And then they give you examples on how you can do the testing. A lot of this stuff, of course, is actuated in the Python notebook files for this unit, but that does cover the content. And there is the bibliography. And we did get some links that weren't working, by the way. But folks, that's a wrap on the lecture materials.